these two things. Very good afternoon to everyone, and welcome to the presentation for the open electives, which will be offered by the Department of Electronics and Communication Engineering to the 6th semester students in the ensuing semester. So, on behalf of the department, Professor Abhishek Deshmukh, I welcome you all for a quick overview of the 4 different subjects that will be offered for the 6th semester students. And as per the subject code, the first subject which is being offered is Nano Electronics with the code 18EC661. And I, Abhishek Deshmukh, I will be handling this semester, this subject. Well, Nano Electronics is also talked more or called more as electronic nanotechnology, and both being vice versa. The word itself has given us, or you must have understood what is in store. So nano electronics is development of electronic devices having smallest feature size between 1 to 10 nanometer, or it can be extended up to 100 nanometers. Okay. Possible devices or electronic devices in computers that can be scaled down into nanometer levels. Those are the complementary MOS transistors. Those can be different memories. We have RAM as well as ROM type of memories. And on a hardware chip or a microcontroller based hardware design, we can have different type of switches or digital switches for a fast operation of the electronic circuits. So these are the 3 areas or 3 devices in which we will be studying about nano electronics. The next, if I talk about the past 140 years, you can see this particular slide where on one axis we have the scale of different operations per second, and we have the timeline on the x-axis. We start with mechanical relays, okay, which had the operation was doubling every 7.5 years. And then we had an era of electronics where we had transistors and their operations or their speed was doubling every 2.5 or 2.3 years. Then we entered microelectronics, where complementary transistors and solid state devices, for example, semiconductors, that is silicon and germanium, wherein operations per second and the development of circuits and electronic devices that speed up to every 1 year. So operations and all other parameters were doubling every 1 year. And then now we are into the nanotechnology era. The graph is much more faster, or it is more exponential. So you can see at the top we have the area where we have, you can see that this particular era of nanotechnology we have already entered, or the humanity into electronics have entered 10 years back. And at 2020 and ahead, we have various avenues where nano electronics is also going into molecular devices. Okay, so we will just touch and understand what are the recent research trends in this subject. Now, if I take you through industrial applications for nanoelectronic devices, we have consumer products. There can be different computer hardwares. We have display devices, and if you have observed your own or people having their own big screens at home, okay, or we have 55 and above inch LED and latest smart TVs. Okay, there is a nano electronic device inside, and definitely in different smartphones, mobiles, and different communication products. It's been a decade. Nano electronic devices have entered. Audio products, especially in sound engineering, we already have nano electronic devices in cameras and film technologies. The devices that you will be taken through in this subject, we have single electron transistors, then controlled electron tunneling to amplify currents and various parameters, resonant tunneling devices. We have quantum devices for current control, and carbon nanotube, which is an area of vast opportunities in research. Okay. Well, nanoelectronics can also be used to create devices. Now they are called as nano electromechanical systems. Earlier, we had micron level dimensions for micro electromechanical systems or devices, and now even those have entered the nanometer regime and renamed as NEMS, that is nano electromechanical systems. Few more other industry applications or industrial products, as I said, memory devices, storage devices, novel and nano optoelectronics, that is also a new arena. Quantum computers, that those are also talked about a lot, even in radio and microwave engineering. We have energy related. Now we have smart grids. So even smart grids have nano electronic products or devices. Now the talk is because of the post-pandemic and the situation globally related to COVID, medical diagnosis and in medical technology or biomedical engineering, nano electronics and nano devices, okay, play a major role. So definitely the subjects, the modules that you will go through in this elective subject, okay, will help you to enter and just understand or initiate your knowledge, to grow your knowledge in the field of medical electronics. If I talk about nanotechnology in India, right from the government of India, state governments, we have different central research centers and premier institutes. They have a lot of research facilities, internship facilities available. So IIT Powai, Mumbai is the premier and the best center for nanotechnology research and its related fields. Another, if we talk about in our own state, we have JNCASR, Jawaharlal Nehru Advanced Research Center at Jakkur, Bangalore, okay, which is also known for research in the field of nanotechnology, nanoelectronics. We have research happening in CSIR and other IITs, IISc in the field of health, environment, and medicines. The government of India has launched many schemes. We have NSTI, then Mission on Nanoscience and Nanotechnology. And there are some links which will be shared with you later. Let us talk about companies. If you are studying the subject, we have companies, those who are doing research, they are involved in production of nanoelectronic devices, that are Intel, HP, IBM, Kodak, Nantero, and QD Vision, just to name few. And I have a small snapshot wherein you can see nano complementary transistors, resonant tunneling devices, single electron transistors, molecular devices, RAMs, and hard drives. You can see there are other companies also listed, those who have research going into these different devices also. So the subject not only is pure based on physics, or it is on semiconductor electronics, but definitely there are a lot of opportunities of internship, research, as well as job in core fields. Okay, it can be for any engineering branch. So the syllabus is into 5 different modules where nanoscience and engineering will be introduced. We will see some characterizations of different devices and structures. We will see fabrication techniques. CNT is a special separate module for you, and applications based on sensors and NEMS. So this is how we will go through this elective subject into 5 different modules. At the end, I can just say it's not only about the size, it's also about the phenomena and the mechanism. It's a wide open field with wide potential for breakthroughs and from fundamental research. And nanoelectronics promise a future in development enhancement of mobile as well as wearable devices and the other fields that we have talked about. So thank you. And I hope for such an interesting subject, it must have brought some attention or inquisitiveness. And I expect that definitely students will opt so that you can know something more and new into this field. Thank you.
So,
This is what they're saying.
okay. So, very good afternoon to all of those who are there. The second elective that is being offered by the Department of Electronics and Communication Engineering is Artificial Neural Network. And myself, Dr. Supriya Shanbag, I'll be handling this subject for the coming 6th semester for the open elective. So let us quickly go through what are the different things, okay, that are involved, how is it relevant and all that. So the buzzword that is currently around us is machine learning, artificial intelligence, even artificial neural network. All these are basically different ways of answering the good old question of whether we can really develop a new form of intelligence that can solve natural tasks. So to put it straight, all of us use Facebook, okay? We use it day to day. So for example, if I would just give an example of ANN, okay? So as soon as we upload any photo onto our Facebook account, the service automatically highlights faces and prompts us to tag the friends, right? So how is that? It instantly identifies which of your friends are there in the photo. So this is nothing but the power of facial recognition system, which is an application of neural networks. Then maybe if I can quote another example, all of us have been doing a lot of online shopping, especially over the last 2 years. Okay, so whenever we are doing this online shopping, we usually find ourselves in situations wherein you said to buy something and then you land up buying much more than you actually had planned. And why is this? Thanks to some super awesome recommendations that the tool gives us. So, like for example, Amazon, when you're searching through it, will return a list of most relevant products which were related to your search without wasting much time. It will actually use all the past patterns that you have used and adapts to what is important for the customer. So whoever is in question, whatever were the previous searches, whatever was the history of that customer, accordingly, the searches will be made. So basically, it is an intelligent algorithm that is running behind, which is actually performing the task of learning. Now, how is this possible? Again, thanks to neural networks. Next, some smart personal assistants that we are so much used to now. So, with the voice to text technology becoming accurate, becoming so accurate enough now that we can really rely on any basic conversations. So, this is actually turning into the control interface for the next generation of personal assistants. So initially, we had simpler personal assistants like phone assistants, maybe like Siri or Google now that is Google Assistant, which we call it now. Then which could perform internet searches, it could perform or set reminders for us, and it could integrate with our calendars. Now, the expanded form of this model with the announcement of complementary hardware and software components we have in place now, that is what everybody is using around Alexa. So all these, just few examples I would put it across to you, which you might relate to, and which are all because of the existence of neural networks. So neural networks, if you can see, I refer this slide. Okay, it gives you the journey of neural networks right from its inception to what it is right now. So neural networks, you can date it back to the early 1940s when two mathematicians, McCulloch and Pitt, okay, they built a simple algorithm that was really based on designing a system which could emulate the function of a human brain. So it was done, but the problem there was lack of computing power that was really necessary to process the large amount of data. And because of this limitation, there were breaks that were put to the advances in their work. However, still it just went on with time, and somewhere in 2000, thanks to the advent of greater computing power and more sophisticated hardware, as well as to the existence of vast data sets, okay, to draw from, computer scientists finally had actually what they needed, and from there, okay, neural network took off. So now here I just put a slide wherein I show a part of it to be human brain and the other part being computer. So what we are actually doing is the lower part is actually trying to mimic what happens in the upper part. So computers have a superior processing power. We all are aware of it. It has a lot of memory, and also it can perform severely complex numerical problems in a very short time and with a lot of ease. But when a real world intelligent task associated with vision, maybe with speech, maybe with pattern recognition and natural language processing, it fails short, and there it shows its inadequacies. So this is because computers need an algorithmic approach. That is the basic problem here. What do you mean by algorithmic approach? Any problem that is given must be presented as an algorithm. And when a real world problem or a task is put, we cannot have formulas defining it all the time. We cannot have algorithms defining it all the time. And hence, computers fail, okay, or fall short to do something like the human brain do, wherein human brain actually has the capability of learning and adapting and does not stick to this algorithmic approach. So there is a basic difference wherein we are much more superior okay, in spite of the ability of computers to do things in a faster way. So here, what is put, I'll not go into much detail here, but what is put here on the slide is a neuron, a single processing element in our human brain. So human brain are so fascinating that even the fastest computer cannot actually compete with, one thing in a human brain, that is the learning ability. So human brain, if I can put it across, we have the capability of learning, analyzing, exploring, and then finally adapting to a particular situation. So all these things are, automatically or naturally taken care by our human brain. So keeping this biological aspect in mind, a lot of scientists have put a lot of efforts in developing computer models that are inspired by this biological neuron, and they can provide a path to solve the problems of natural tasks. So this approach that has been used, okay, in order to solve problems by mimicking the ability of a human brain is what we call artificial neural networks. So artificial neural networks are basically modeled after the neural networks of the human brain, and they are responsible for, maybe human decision making. So the brain takes in information and then attempts to connect the dots. It comes up with a particular conclusion. We don't actually get it right maybe at the first time, but then there is always a learning that is happening. Once when you learn things, then the next time you get adapted to it, and there will not be any error and will be able to solve. So this kind of an approach is also used in uh, artificial neural network, wherein this capability of human brain, okay, is emulated by the system which now you see at the bottom, which is artificial neural network trying to mimic all the capability and functionality of the neuron which is there at the top. Okay, so if we want to go into much detail, but this is how each and every function of the biological neuron is copied, okay, and made to function, okay, not as a natural way but in an artificial way. So next, here I would just like to highlight a few of the applications, maybe in various fields. Okay, because in an open elective we have students coming in from different departments, and each one would like to know what would be the idea of studying this subject and how it would be useful in my domain, right? So each one will have curiosity, and just to put it in brief for a few of the important areas. So in maybe in the area of aerospace, the aircraft component fault detectors, okay, simulations, aircraft control systems, uh, high performance autopiloting, all these things which are in place now are all because of neural networks. Okay, so automotive. So in automotive industry, you see improved guidance systems, then voice simulation, and so many other applications you can think of when you put it into electronics. Then manufacturing, if you are into the manufacturing unit, then dynamic modeling, okay, of the process system, process control, planning and management, quality analysis, uh, visual quality inspection systems. All these things are there in place in the manufacturing unit as well, again thanks to neural network. Then we have robotics. Okay, so in robotics, manipulator controllers, trajectory controllers, vision systems, all of it is again owing to neural networks. Then we have telecommunications. In telecommunications, ATM network control, data compression, equalizers, routing and control, signal processing, uh, speech recognition, all these contribute to what we have as the applications of neural network. And most importantly, medical field has a tremendous application because of all the advances that has been done in this field, especially of neural networks. So in medical field, we see cancer cell analysis, EEG, ECG analysis, quality improvement in the hospital systems, transplant process optimization, prosthesis design. All these contribute, okay, towards neural network applications. So these are the different domains, but we are not limited to this. If you see the area of banking, business analytics, defense, maybe sector of education, transportation, everywhere we see, somewhere or the other, ANN in the sense, artificial neural network is playing an important role. Okay. So here, if you see for engineers, advances in neural networks that have been made, deliver endless opportunities for experimentation and also for creative problem solving. And neural network is getting popular in all the walks of life, and especially being applied to automate and optimize the process of solving challenging tasks. So quickly, the objective of our course would be to provide the students with a sound and comprehensive understanding of ANN. So we'll be understanding what it is. Then we'll have an emphasis on different learning architectures and strategies which are used. So those are important. Then we will explore the variety of problems and apply the neural networks techniques with the help of simulation to solve such problems that we have identified. And we will have a certain comparative analysis that we can carry out in order to decide, because there are a lot of possibilities of architectures in neural networks that are possible, which one could be suitable for a particular task. So comparative analysis can be thought of. And we would promote what we call as independent learning on the topic of neural networks through our activities that we will be taking up in the course. Okay, so there are a lot of things to gain from this subject of neural networks, and the scope is actually vast. Everything is converting into automation, as I was telling you earlier. Hence, there is a need of efficient dealing with changes and adapt to these changes accordingly. There is a lot of research going on in developing new technologies based on neural networks. And eventually what is going to happen is, since everything will be automated in all the sectors of life, neural networks are going to play an important role. And if we are in line with this technology, if we are aware of this technology, it would always be beneficial to us in whatever sector we are working. It would always be useful. So due to an increase in new technologies, there are many job openings for engineers and neural network experts. So if we have an idea, if we have an understanding of neural networks, obviously it is going to add some value and better chances of having a good job openings. And in future, neural networks will prove to be 101% a major job provider. So it would always be a good idea to at least have a flavor of this subject, even if it is not there in the regular course of your syllabus. A flavor of it is still possible by opting such subjects through open electives and understanding, at least introducing yourself. Once when you understand, okay, you have a feel of it, you can go into much detail and by taking up further subjects like deep learning. So this would be a fundamental subject which would give you an introduction to basically neural networks. And in any field you are in, it is surely going to be helpful. So with this, I will ask my colleague to carry out with the next subject. Thank you all of you. Good afternoon, student. Myself Vaidehi Deshpande, and I'll be handling the subject Embedded System Design. Okay. The subject code for Embedded System Design is 18EC 663. Okay. So, what is embedded system? So, before we start with the complete embedded system, I would like to tell you about what is called as system. Okay, a system, it is nothing but an arrangement in which all its unit assemble work together according to some set of rules. Okay, so for an example, I can give you. You have a watch. Okay, so a watch is used to display a time. So it has certain components, and those components has set of rules. Okay, to show the time. Now, suppose if any one of the system or any one of the part in the watch fails, then what is going to happen? The watch is, of course, going to stop, right? So, similarly, in a system also, they have each sub components. Okay, so each of the sub components are dependent on each other. Okay, now next we'll come to the part called as embedded. So embedded is nothing but it is a combination of hardware and as well as software. Okay, so why this embedded is used is it is going to perform a specific task. Okay, or also you can say that it is a microcontroller or a processor based system which is designed to perform a specific task. Okay, so in our day to day life we make use of this embedded system. So I would like to give the example in my next slide. So before I go to the applications of embedded system, I would like to tell about the companies which are working on embedded system. So there are n number of companies which are working on embedded system. So I have taken some of the examples here. So one is Delphi, Wisdom, Qmax, Cornet, Bosch, Tata Elxsi. So there are n number of companies which are working on embedded systems. Okay, so now I would like to take up some of the applications what we have in an embedded system. So as you can see here, it may be your RFID system, it may be your barcode scanner, it may be your alarm system. Okay, all these components, all this are performing a specific task. So since each specific tasks like so suppose an alarm system. So in alarm system, you have cameras, you have CCTVs, okay, you have fire alarms. Now fire alarm system is going to perform a specific task wherein if there is any fire, it is going to turn on and it is going to indicate that there is a fire in the house or anywhere wherever it has been connected. Okay, so this embedded system is nothing but it is trying to perform a specific task. Okay, now take an example of a biometric system. Now day to day life in every place, in every workplace, we have this biometric system. So what does this biometric system does? It records the person's attendance, right? So every person gives its attendance in a college or it may be your office through a biometric system. Okay, so these are some of the applications wherein embedded system is used. Okay, so one more best example I would like to give is your car. So you use Honda, you use costly cars. Okay, so all these cars are working based on this embedded system. Okay, so the idea behind the working of the automotive car system is nothing but your embedded system. It may be your car dashboard, or it may be your electronic control unit, it may be your traction system, or it may be your anti-lock braking system. All this perform the task with the help of something called as, or the idea behind the working of dashboard or it may be electronic control unit is nothing but your embedded system. Okay, so then next, why we are going for embedded system? So why embedded system is because it has so many important features, or you can say characteristics, like it is having very low cost. Okay, it performs a specific task. Okay, it is highly efficient, high reliable, it is stable, and it requires very less power, because of all these features, why we are going for embedded systems. Okay, so then next is why we are the prerequisite for this subject is you should have a slight basic knowledge of programming your language in C. Okay, so the objectives of the subjects are you have to understand the concept of the first chapter, or the first thing what you're going to study in the embedded system is you need to understand the concept or the design principles. Okay, the basic what we have, what is embedded system, the difference between the general purpose system or your specific system, that is your embedded. Okay, so all the basic concepts are being covered in the first unit. Okay, so in the next unit you're going to study the hardware components which are required to study the characteristics or attributes of the embedded system. Okay, so in the third you are going to study the interfacing between the hardware and the software system. Okay, so the different types of communication protocols like I2C, it may be a CAN protocol. Okay, there are different sets of communication protocols which are very much required for your industry as well as your uh, what you say the things which is required to communicate between the software and the hardware is being studied in this third chapter. Okay, so the fourth unit covers the basic task, process and architecture of real-time operating systems. Okay, so what is real-time operating system, what are its architectures, what are the basic tasks and the process that is being performed by this RTOS, we are going to study in this particular unit. Okay, and the last is how you are going to perform or how you are going to design a small program or simple applications which can be used as or which can be taken as an example for embedded. Okay, embedded systems that is being studied in the last unit. Okay, so mainly an embedded system has three components. One is hardware. Okay, then application software, and the third one is it has real-time operating system. So these are the three set of important points which are there in your embedded systems. Okay, so last but not the least, in the subject you are going to study the overview of embedded system, the various steps which are involved in their design, development and the major domains where they are going to be used. Okay, so these are some of the set of applications, these are some of the companies which are working on embedded system. So there is lot more to study related to embedded systems, especially for the computer science. You might have studied the software part. Okay, so how it is going to work on the hardware, or how you're going to develop the hardware system, that you can correlate with your software as well as hardware in this particular subject. It may be computer science, it may be information science. So everyone might have studied the basics of C programming. So that basics of C programming is going to help you study this subject which is called as embedded system design. Okay, so the first three chapters are more about theory. Okay, and the last two units will be last one unit will be the application development of your embedded system. So with this I would like to conclude my introduction to embedded system design, and I would like to ask my colleague to continue her subject related introduction.
Good afternoon, students. This is Professor Priyanka Joshi from Electronics and Communication Engineering Department, and I'll be taking the last open elective of 6th semester, which is Internet of Everything. In short, it is called as IoE with the subject code of 18EC 664. So now you must be wondering and asking, what is Internet of Everything? Okay, what is everything means within the internet? So I put here the in short definition of IoE. It is a concept that extends the IoT, Internet of Things, which emphasizes on the machine to machine communication to describe a more complex system that also encompasses people and processes. So, IoE is moreover to the IoT only. Okay, so IoT basically refers to a system of interrelated or interconnected objects that are able to collect and transfer data over a wireless network without human intervention. So, the personal or business possibilities in this IoT are endless. Now, next, I put here this slide for the market map of IoT. You can see here there are n number of companies which work basically on the IoT devices. So we can say IoT is a buzzword into the market which has n number of devices connected to internet and which is basically used for the connection of end-to-end devices and for a better communication. So there is, yes, a lot of opportunities available in the IoT market. So there are a few companies of IoT in India as well. The Algo Engines, the Altex Innovations, the IBM, iBot Technologies, the Pixel Crayons, and so on. Now basically we'll focus on what is Internet of Everything. So in one slide I can explain you it is related as a network connection of people, process, data and things. So which includes basically everything. So it is termed as Internet of Everything. Okay, so here the basic concept is referred to as a smart and connected. So smart in sense of applications which you are using the IoT devices as wearables in smartwatch or smart bands basically. Okay, so not all the devices, IoT devices need an internet connection to function properly. But yes, they do require a connection to gather the gadgets on the network to automate certain tasks. So there are n number of examples in IoT which I can tell you, which basically connects a variety of sensors, alarms, cameras, lights and microphones, which provides 24 by 7 and 365 days of security, all of which can be controlled from a smartphone. Yes, through your smartphones, you can control everything around yourself, and which basically leads to a high security area. So, a few of the applications wherein IoT is majorly being used are smartphones and smart home basically. So the smart home is the most popular IoT application, which allows the user to access the home appliances like lighting, heating, security, and entertainment remotely. You must be using the Netflix and YouTube, which have become the necessity of today. So all these we have connected to the smart TVs, to the internet, and which allows us to browse the various applications. Now, the second major application of this is wearables. So, wearables include the smart bands basically. It also has the smart bands for blinds as well. Then the smart city which has many solutions under the smart parking, waste and water management, smart street lighting, and smart surveillance. The next application is waste management and water management, which are turning out to be the better for the environment as well. The smart grid, industrial IoT, yes, IIoT is the major area of extended IoT technology for manufacturing and industrial processes. The connected cars, connected healthcares, smart retailers, the smart supply chain, smart farming. There are n number of endless applications of IoT wherein you can have major case studies to study for in this syllabus. With the increasing usage of IoT in different sectors, the demand of IoT experts are also increasing. And with this, a good research also you can do in this field, for which I would suggest you to go for this subject so that you will have a crisp of all major areas wherein you will have the different modules in this subject. So basically, going for the objectives of this, herein you will be studying the basic principle and framework of IoE, wherein you will be having the introduction to the Internet of Everything. Then they simulate the application with different data acquisition techniques in Internet of Everything. So here you will be studying the IoT applications for industries, which basically includes the IIoT. Then the third objective is to develop the application of IoE in various industrial environments. The fourth objective is to study the wireless sensor network architecture and various security features, which will be having major sensors to connect in a remote fashion, through which you can have access to the remote areas and which will add on the security features as well. So this majorly goes to the wireless field or wireless network area. Then the fifth module basically has the IoT privacy, security, and governance. So which will going for the fifth objective, which is to comprehend the security and privacy issues in IoE. So these are the 5 modules which you will be studying in this subject. So lastly, I can say that the future of IoT has a lot of potential to be limitless. So I would like to have students from different departments to study this subject, which is Internet of Everything. Thank you all. With this, I conclude the introduction to the open elective session.